Hi, this is Steve Michelotti from Azure Government Engineering Team. I'm joined today by Vishwas Lele, CTO of Applied Information Sciences, and we are going to talk about building real-world solutions on Azure Government with machine learning. Welcome, Vishwas.
Thank you, Steve.
So why don't we start out by you just kind of giving us a high-level overview of the solution in question here that you guys built.
Sure, Steve. So this is the solution that we built for a government agency, and I should say a classified government agency. And later on in this talk, we can look at some of the solution elements. But at a high level, a very interesting solution, when we met with the customer, this was a manual process. So, think of this organization that is comprised of a number of policy analysts that cover different policy areas. And as you can imagine, a lot of documentation and articles and news stories and internal documents are fed to them. And there used to be a manual process that a team used to come in early in the morning and classify these documents in order to make it productive for these people and make it available to them. And we said, can we apply machine learning to this problem? So we created this machine learning-based solution, which I'm here to talk about. So if I can, get into the solution description.
Absolutely.
Essentially, the solution is really involves three things. The first thing we do is there are a large number of documents that are coming in, and it's really impossible for someone to go read these documents. So we wanted to use a machine learning algorithm to auto-classify these documents. And then once we have sort of auto-classified these documents, and I'll talk about the algorithms involved in a moment, we then recommend these documents based on, so you are working on a certain policy desk, and you've told us that these are your preferences. We'll match those preferences with the auto-classification. And the third component of this is that, let's say we have made the recommendation to you, and now you've read this article and you think that it is really a valuable article, and maybe other members of your team may be interested in it. So we take that feedback that you provide and then apply it back to the machine learning algorithm so that others can benefit. So in a sense, we are training that algorithm constantly based on the user feedback.
I see. So no matter how good the human is at their job, sort of a scalability limit. I, as a single human, can only go through so many documents at once. This enables us to get higher level of just throughput in terms of how many documents you can analyze, as well as if you come to me and say, hey, Steve, your recommendation wasn't that good, or hey, I love that recommendation. Again, me as a single human, if I have to now keep track of that through lots of feedback channels, that becomes difficult. Something computers are really good at.
Right. And there are some really good algorithms out there that can help with that. So, with that description of the document, if I may go to the next slide, Steve, really talk about the solution elements. So this is, the original solution originated in Azure Commercial, and we've ported it to Azure Gov. And the elements that you see on the screen are the elements that make up the solution. So we have API management, and we'll get into why these elements came into play. We have API management, app service, web jobs, Cosmos DB, and machine learning server. And it will help. So keep this in mind, and then we'll look at the diagram and we'll call out all of the individual pieces here.
One thing I love about just seeing this list is that a lot of these are PaaS services, platform as a services. So it's not like you guys just had some application and threw it over to a bunch of VMs in IaaS. You're actually using these higher level services to make the solution more efficient.
Absolutely, and that's the goal, that wherever possible, use the higher level services. And if we need to drop down into IaaS, absolutely do that.
Awesome.
So these are the elements, and then when we look at the diagram, these elements will become clear here.
Great.
So let me bring up the solution architecture here and walk you through this. On the top left corner let's start with, there is an Azure App Service where our API ultimately is hosted. And this information, this solution, the way it is made available to the consumers is through a SharePoint portal. For the purposes of this discussion, we will not go into the intranet in SharePoint, but ultimately it's a web part in SharePoint, which calls this API. So Azure Web App is hosting our API. Web App is also hosting something interesting. It's hosting a web job, which is responsible for running every night. And we provide it with a list of data sources, and it brings that data and stores that into Cosmos DB. So we're pulling this data every night into Cosmos DB.
And even the simple fact that you guys surface this as an API, the UI, in this case, is SharePoint, but it could have been a regular web app.
It could have been.
Because you surface as an API, you have that flexibility.
Absolutely.
Great.
So that's one thing. So once the data is in Cosmos DB, then we apply a machine learning algorithm on it. So you were talking about, humans can only read a certain number of documents. So we are using a tool called the Microsoft Machine Learning Server, which your viewers may know as R Server previously has been renamed to Microsoft Machine Learning Server. And the real power of that tool is it can either run in a standalone Windows or a Linux server, or it can run inside SQL Server. And it gives you the ability to run R and Python programs. And what is really interesting is they give you a bunch of algorithms out of the box, but then also you can bring in open source algorithms as you see fit. So when we were building this experiment, and Steve, I'm not a data scientist, and we started out with some algorithms and we tested it, and the users liked some of the results, did not like other results. So we ended up with an algorithm that was developed by a gentleman named David Bly at Princeton. I think he's at Columbia now. And he did some really interesting work called topic modeling. And the idea is that he looks at a document, and then by looking at this document, using this algorithm, he comes up with a probabilistic model of what this document entails. What are the topics covered as part of this document? And fortunately enough, not only he published that paper about how he does topic modeling, he also gave us, not us, but he published an open source package, the R package, for that algorithm.
Wow.
And we took that algorithm, brought it inside the Microsoft Machine Learning Server, and then that algorithm then applies that on the incoming documents inside Cosmos DB.
Wow, okay, that's amazing. So let's break this down a little bit. You're using Machine Learning Server,
Yep.
so you have your choice whether you want to use R or Python, personal preference.
Yep.
In this case, I think you guys selected R.
Yep.
You have your ability to bring in some out-of-the-box libraries, even open source libraries you can bring in. And in
Yep.
fact, that's what you guys did by bringing this gentleman's library.
Yes.
Okay,
Yes.
so you have a lot of flexibility in how you can approach this and solve the problems.
Right. And it's very interesting. The reason, or one of the reasons this algorithm was developed was David Bly supports digital historians. So let's say, 2 million cables or telegrams got declassified. Now, whose job is this to read those 2 million cables and figure out what was being talked about? So he developed this algorithm for that.
Wow.
And then, of course, we were able to use it in this instance.
Okay.
So once you have this algorithm, we make a call into this algorithm. We figure out how to classify these documents, and then we store the results back into Cosmos DB.
Okay.
And then we have a web API, which supports, getting the documents based on a user's preference. And then there's one other final component. We have a number of moving parts here, but the final component is the API management layer, which is super critical in this case. We did not want our callers to directly talk to our web API for multiple reasons. They could have very well done that. But API management offers us the layer of indirection, which really became important for us. As I mentioned, this is the classified agency using this project. And API management, because of that layer of indirection, allowed us to inject some interesting policies. For example, we said, only allow the IP address range from that intranet to come in and call our API. And the other API that we put in place, or other API policy that we put in place rather, was, the SharePoint web part goes ahead and gets a JOT token. And that JOT token needs to be sent into the API management for the call to be serviced.
Okay.
So it allowed us, without really burdening the web API with these kinds of details, we were able to externalize that, put that in API management, and make it available to the SharePoint web part. So these are all the components that we talked about.
Very cool. So with Cosmos, that was providing a lot of flexibility, not only for storing the data after ingestion, but also after machine learning runs, store the results also in Cosmos.
That's right.
Place.
That's right.
And then with an API, we talked about the API is great because you can have any type of UI. But here you guys also used API management in Azure Government to be able to apply these policies. Could be security policies like you guys did here, or a host of other ones as well. And as a developer of the web API, whoever was tasked with that responsibility, they didn't have to worry about all those policies. They could just create the logic of their web API without being burdened with, like you said, knowing what the policies would be. It might change.
That's correct.
You don't have to put that right in the code.
And another example would be a caching policy.
Right.
If the content can be cached, then we can improve the response times to our users. So there are a number of benefits. And of course, you can now write policies yourself. You don't have to use out-of-the-box policy. So there's a real power to that in putting that in place.
That's awesome. All right.
So that's sort of the high-level overview of the architecture and why this solution came into being. Would you like to see a small slice of this application?
Let's have a look.
So let's just exit out of this PowerPoint here and let's just go into the Azure Gov portal in this instance.
Azure Government portal here. Okay.
We're in Azure Government portal. And I have a resource group called the ML demo. And for the purpose of this demo, we took parts of our application, brought it here so we can share with your users here.
So the PowerPoint you had where you listed those Cosmos DB, API management, we see you have these resources, so I can associate what was on that PowerPoint slide to the resources we see right here in the portal.
That's a good point, Steve, because, let me just call out a few of them, right? Yeah. So we talked about API management right here. We have Cosmos DB, which is where our ingestion is happening. The web jobs are coming in. I will talk about the ML demo server. Remember, I talked about the machine learning server, which right now is a standalone server running on this virtual machine. Yep. And then I can scale it out if I wanted to. And then, you see a bunch of disks, storage accounts, and things like that right here. Okay? So that's the entirety of the solution. And just to give you a flavor for a couple of these things here, let me go into the API management portal here. This is, as you know, there are two portals that come with it. One is the publisher portal and then the developer portal.
So the publisher portal is, I'm an author of an API, I want to set up my policies.
Absolutely.
The developer portal is, I'm a consumer of the API and I want to kind of see what it's available, try some things out.
Yep. So I'm in the publisher portal right now, and I just, not all policies have been enabled. I commented out a couple of policies, but very quickly to show you here that, I have a jot policy right here that we were talking about, right? So you have policies, and as you said, Steve, that, I have, this is the dashboard. It gives me information about how many APIs are being called and, what is the most popular method. I get a lot of information about that. And then if I go over to the developer portal, and let's just go up here, and these are the three methods here that, Steve, we should talk about here in a moment here. So, the first method is, here are the recommended news stories based on the user, right? And the other method here that I want to show you is, given the user, please give me the categories that I'm interested in and what categories apply to me. So those are the two examples here. In fact, if you have time, we can just quickly execute one of them.
Absolutely.
So you know that this is not just an empty demo.
Yeah.
So give me the news stories for this user. And the developer portal is nice that it allows me to exercise this API very quickly without having to write any code. And we put some default values. And let's just go ahead and run this. So it is going to, for the users, let's just say this is the endpoint that we were looking at earlier. So ML demo API management. API.us, of course. And then this is the URL. And if we go ahead and run this, it'll come back with the stories that I may be interested in based on the preferences that I have set. So these are all the stories that are coming back.
So if I'm a developer that's been tasked with the job of consuming this API and getting these stories back, what API management is enabling for us here is saving me from having to maybe go to documentation that might not be too good.
Yes.
How do I make this API? Do I need an authentication token? Do I need this and that? I can just go right to this API management, try it, and in seconds, I can actually be making calls to the API.
Absolutely. There's a common term that the API community uses, which is, how much time does it take to make the first successful call? And you and I, we've all been there. You are both developers, and we've seen that if that time is less, anything more than 5 minutes to get my first method successfully executed, it's too long. Developers are impatient and they move on. So this gives you, come in, explore the API, and be able to invoke it very quickly. Right. So I wanted to quickly show you this. I just want to also just very quickly go to the machine learning server, Steve. Let me just maximize this here. And here is the web API. That is, let's just bring up the code here. In fact, I have some things open right here, the controller right here, and these are the two API methods, and this is the one we call the get recommended model.
So this is the API. When we saw API management, this is actually what's in front of the code that we're seeing right here. That is correct. Okay.
That is correct, and thank you for pointing that out. So API management is essentially a facade. So when you onboard your API, in your API management, you need to provide what backend API would it be calling.
Yeah.
And that backend API is the app service web API. And the code that we are looking at is indeed the web API controllers for that.
Great.
This
is just out of the box.
This is just out of the box.
We're used to seeing all the time. Okay.
Absolutely. Absolutely. This is the part that, Steve, I want to talk about just for a moment. So remember we talked about that, this machine learning server gives us the way to call the R package and the Python package. And of course, the hard parts of these algorithms are written in R.
Yep.
And we of course have to execute those on the R server. But in order to call the R server, we decided to use as much C# as possible because there's some data manipulation that's happening, all done in C# link. But then we're using a package here called the r.net, which allows a C# program to call the R package. So going further down here, I just want to point out the one that is really of interest here, which is the process LDA. And this LDA is that algorithm that the gentleman David Bly had built. And it stands for latent Dirichlet allocation, some fancy term which we need not be concerned about, but it's essentially a complex R package. So you can see here, I'm in C#. I did some data manipulation and ultimately calling that R package, which is just returning the data. And then because I'm in C#, it just makes it easier for me to interact with Cosmos DB at this point.
So being a C# developer myself, I think we need to take a moment to bask in this, what we've just seen here, because I'm not a data scientist either. You mentioned that earlier.
Yes. Yep.
I can write my C# web API, but now it's time to call a machine learning algorithm. I can just write a line of C# code and call directly into this machine learning algorithm on an R server. That's pretty powerful stuff.
And there's another reason. I knew that you're going to stop me here, so I came prepared. There's one other thing to talk about, right? You're talking to Cosmos DB, and there's no easy way to talk to Cosmos DB from R. And maybe somebody will correct me and tweet and say that, well, you can make a REST API call from R. You can, but there's a lot of work in setting up the tokens and things like that. So by having the code that we have in C#, it allows us to transform the code and then using this package call the R libraries and then interact with Cosmos DB. I should say that another approach, if you don't want to use this .NET R package, is expose that R package itself as a web service.
Okay.
And then it will be a seamless interaction. So that may be a preferable option there as well.
Great.
So that's essentially the code, Steve, of how this all came about. And the solution is running in Azure Gov.
Okay, that's very cool. So not only are we running machine learning on Azure Government, but we're using all these PaaS services, Cosmos DB, web jobs, app service, API management. That's really cool. Focusing a little bit more on the machine learning, I know that you have a lot of experience doing machine learning. You've done this with Azure ML and ML Studio and Azure Commercial, with Azure Government, HD Insight, Jupyter Notebook, Spark clusters here. We're looking at machine learning server. Can you just give us your thoughts from what the experience is like with these different tools and doing this on Azure Government?
Yeah, so that's a really important question to consider because, yes, as you said, we have done a lot of work with Azure Machine Learning and both with the ML Studio. And when we were converting this solution over to Azure Gov, Azure, the machine learning server proved to be a really useful tool because not only could we bring the open source libraries that I talked about, and in fact, there's another library that we are also using, which we didn't get a chance to talk about, which is called the entity extraction. That is another R package that we found. So this ability to take these open source packages and then run them on a scalable R or a Python engine, and this ability to run it completely inside your virtual network, where it can be sensitive data, I think it opens up a real possibility for doing ML in this manner in Azure Gov right now.
Very cool. Okay, well, thanks for joining us, Vishwas. This has been Steve Michelotti with Vishwas Lele, CTO of Applied Information Sciences. We've been talking about building real-world solutions on Azure Government with machine learning. Thanks for joining us.